Azimuthal quantum number. It is represented by the letter L. Now it is also called orbital angular momentum or subsidiary quantum number. Orbital angular momentum or subsidiary quantum number. You just have to remember that it defines the three-dimensional shape of the orbital. It defines the three-dimensional shape of the orbital and it is represented by the letter L. Then its value is equal to the total number of angular nodes in the orbital. That is, for a given value of n, say principal quantum number n, L can have n values ranging from 0 to n minus 1. So, it will depend on the value of n and L can have n values ranging from 0 to n minus 1. Then, each subshell is assigned an azimuthal quantum number L. If the value of L is 0, then the notation for that subshell will be S. If the value of L is 1, then the notation for that subshell is P. If L is 2, then subshell is D. L is 3, subshell is F, etc. You are familiar with S, P, D, F subshells. Now they are assigned a value of L. So the values are given as 0, 1, 2, 3, etc. And the notations are S, P, D, F, etc. The number of subshells in a principal quantum shell is equal to the value of n. So the number of subshells in a principal shell is equal to the value of n. We can just look at this table and we'll understand that. If n is 1, then we know that L is 0, that is n minus 1. L is 0 and the subshell, name of the subshell will be 1s. If n is 2, then L can have two values, that is from 0 to n minus 1. So that is 0 and 1. If the value of L is 0, then the name of the subshell is 2s, and if the value of L is 1, the name of the subshell is 2p. For the third principal quantum number, that is 3, L can have three values, 0 to n minus 1, that is 0, 1 and 2. If it is 0, L is 0, then subshell is S, 3s. If the value of L is 1, then the name of the subshell is 3p. If the value of L is 2, then the name of the subshell is 3d, like that. So the number of subshells will depend on the n or principal quantum number. If n is 1, it can have only one subshell. If n is 2, it can have two subshells, 2s and 2p. If n is 3, it can have three subshells, 3s, 3p, 3d. If n is 4, it can have four subshells, 4s, 4p, 4d, 4f, etc. So this is azimuthal quantum number. It is represented by the letter L. The main points are, it defines the three-dimensional shape of the orbital and its value is equal to the total number of angular nodes in the orbital. That is, it has value from 0 to n minus 1. And each subshell is assigned an azimuthal quantum number L. 0, if L is 0, subshell is S. If L is 1, subshell is P. If L is 2, subshell is D. If L is 3, subshell is F. And the number of subshells in a principal shell is equal to the value of n.